convinced everything's going to work on the first try, but hey, it's working. That's good news. And the red dot is going to tell you about where my eyes are most times. Usually I'm going to just be looking at the clock unless anyone has any questions. And we'll always start class right at the 1 o'clock mark. So welcome back, folks. It's now the official time to start. If you came into Zoom or came into class right at 1 o'clock, that's when everything starts officially. So you'll never have missed out on anything. Well, let me bring back my annotation. I don't have too much here, but welcome back, folks, to the spring 2026 semester. This is going to be a pretty interesting class for us because we have an in-person section as well as a fully online section running together. So they give us a lot of those kind of classes down here at Idaho Falls. This one originally started off as an in-person only section, and then sometime in December, they added the online section as well. And it looks like it's kind of split half and half. If you registered for the in-person section, that's this one, section 06. The thought is you'd be in the classroom CHE 215. You're going to take exams in the classroom CHE 215. And if you're in the online section, that's this one, 3350, section 16, then more likely than not, you came in through Zoom. You're going to be taking exams in either the Idaho Falls Testing Center, the Pocatello Testing Center, or maybe one of our more remote testing centers like in Twin Falls or Pocatello. So whichever section you're registered for, if you're, say, registered for the 06, but that's because the 16 section filled up, that's going to be okay. I'm not going to be too worried of where people are in these two different sections. If you're in the 16 section, but you're actually an in-person student, vice versa, again, that'd be just fine. But those are the first things I want to talk about just to start us off. Today we'll be mainly introducing the course, introducing the tools and elements that we're going to be using day by day in the Canvas website, and then go through some of the notes for our first chapter 1. But before we do any of that kind of stuff, any other questions to start us out today, folks? Okay, well, let's get started. First, because this class is kind of weird as a hybrid class with an in-person section and online section, one of the things I want to show people, particularly if you're in Zoom, because you can't see as many controls, this is what my screen actually looks like. Let me move that over here. It's really pretty busy, and it's hard to actually fit in extra things like, say, for example, if those were the lecture notes and we're using RStudio as a calculator, it's hard to actually see all that stuff unless I start hiding a whole bunch of things. So the first thing I hide, sorry about that, is this entire screen right here. So you don't have to be on camera. I'm not too worried about that. I'll often be on camera because it'd be weird if I turned off mine. So first thing I do is I just hide this. I just kind of tuck it up here so I can see who's talking. I pay a lot of attention to this part right here, or at least I try. I have kind of a tunnel vision with my eyes, so it's hard to notice everything at once in class. But I'm often looking right here. So it'll inform me who's talking. If you have a question, you can raise your hand if you like, or you can just interject over voice. That's fine as well. You can give me ideas like thumbs up to give me some information if you have questions or not, how things are going. And I'll try to do my best to pay attention to reactions here. I'm also going to be paying a lot of attention to the chat feature. Let me show you what that looks like. Or at least try. Here we go. One more try. So as far as participating, I'd say the best way to participate is using the reactions, using your microphone, voice, that kind of stuff. But chat's just fine too. I'm not opposed to you using chat. That might be the most comfortable thing. If you're in, say, maybe a louder setting, that kind of stuff, dogs barking would be a problem I have. So I'm going to try my best to pay attention to chat. But that one is also pretty tricky for me because sometimes my eyes have tunnel vision. And when you send a chat through, this little control right up at the very top kind of pops out just a little bit and lets me know that there's a chat. If I miss that, anybody in the class, please interject and just say anything along the lines of, hey, Mike, you missed a chat. And I'd be very appreciative of that as well. And I get better at these kinds of things as semesters go. So I'm going to be looking here and up here at the same time, trying to do the lecture all at once. And those are going to be the great ways to participate, particularly on the Zoom side. As far as the in-person section goes, participating is a little bit easier. You're all right here. It's a little bit tricky too, because we're running Zoom through this so-called OWL camera, but I probably shouldn't lift that up while it's running. They're getting a little old. The microphones are not the best. And so if you're participating in class, you actually have to project really loudly for anyone to hear you. So sometimes I might just say back your question, something like that, so it gets into the recording. People can hear it in the Zoom class. So it kind of feels redundant after a while. If I ever forget to do that, if a question or a comment was made in class, but no one could hear it over Zoom, that's a great time to interject as well. You can just say anything along the lines of, I didn't quite hear what you said in class, and that'd be just fine. So that's how participation is going to work with this kind of a strange, janky setup that we have so far. Let me close these things out. And the next thing, again, we're going to be doing in class today is really just introducing some elements in the syllabus, not a line-by-line reading, but a quick run through, look through Canvas, and then get started in chapter 1, just doing a few problems. Any questions or comments so far, folks?
So I can like this time
Oh, no worries. Sorry, say again? Okay, yeah, that'll be just fine. So for the Pocatello section, if you're registered on this one or on this one, either is going to be just fine. So I think that's one of the comments I was about to make, but I didn't quite get there. I'm not too sure. I'm not too worried about which section you're really registered for. So if you are on the online section 1.6, you're on the Pocatello campus, you're just fine to come down here today and join any class.
No,
What-
register the one for, I don't know.
Gotcha. And if you're in the Idaho Falls section, you're welcome to come into class each and every time. That'd be the kind of expectation. But if there's some weird days, like maybe you're just in Pocatello, maybe there's a lot of snow on the road, and you want to come in through Zoom, like the online section, that's fine as well.
Oh,
So in other words, I'm not too worried about how you participate. If you come in through Zoom or come in person in class, I'm not going to be worried about, hey, you're in the online section. What are you doing here? That'd be never a thing that comes up. So if you're here, I'm happy. If you're here in person, I'd say that's great. If it was a weird day to come in and you had to come in through Zoom, that's just fine as well. Other questions or comments at the moment? Okay. So, well, we've been pulling up the syllabus. That's the very first document right there. This one you might have taken a look into if Canvas is brand new to you, but I think a lot of people are possibly skipping that over. Other element on the Canvas is this is the Zoom link and password. So everyone over here on the Zoom side, all 9 people, I guess that includes me, has found that information. And if there's a day you need to come in through there, that's where that information is found. Another thing we're going to be doing all semester long is recording the lectures just as an extra resource so you can use for studying and so on. Record lectures will go into this playlist right here. And if anything seems missing, say Thursday or Wednesday lecture is just gone, please let me know right away. I probably just forgot to add it to the list. Next is going to be some other elements we're going to be using in class. So let's jump back to the syllabus before we go to that RStudio link. As far as the class runs, it's going to be pretty traditional within reason, since we do have an online section like we mentioned. We meet at the same exact time from 1 to 2:15 p.m., just in different modes, different places. As far as contact information goes, I have my cell phone here, and I wrote the best way to contact me is by email, since that's the mode that I pay the most attention to. My cell phone is pretty much silenced almost all the time these days. Course webpage is nothing fancy. That's just the Canvas page, a direct link to it. As far as the office hours goes, it's basically right after class. So right after class, you'll be in this room, CHE 215, or you'll be in the Zoom meeting that you're in right now. It'll be from 2:30 p.m. to 3:30 p.m. This will be Monday through Thursday. So if you have questions right after class, in person or online, just hang around. It'll be happy to help out. I do these office hours for each one of my classes. So you might notice at 2:30, someone from a totally different class comes in. And that's just fine as well. We'll just kind of go in order, addressing questions as they come. Next is the course textbook. As far as this edition goes, if you have the fourth edition, I'd say that's great. But any edition of the textbook is going to work fine. Even the first edition is really, there's not a lot change from the first edition, even to the fourth edition. So any edition of the textbook is going to work out great. I encourage you, just get a cheap edition. You really shouldn't be spending more than, I'd say, $50 for an edition textbook in this class. The reason any edition works is the chapters are the same, the formulas are the same. And as far as the homework goes, I write up my own homework assignments, so everyone's going to see what those would look like. Some of them do come from the fourth edition. Some of the homework sets are custom problems. And that takes us to that RStudio link. As far as the required software goes, we're going to be using the statistical software R. We'll be using it through something called RStudio, which for the computer science people, that's referred to as an integrated development environment. But the practical way to say it is it just has a lot of things that makes life a lot easier using R through that package right there. And I wrote out a really big blurb on why using RStudio. This was a question that used to come up a lot back in the day, say around 2014 and so. It doesn't come up as often. I think people are kind of getting more used to this just being statistical software. Usually if you're taking an intro stats class, you might be doing things in the TI-84, but that has limitations, right? You're putting in data line by line. And what do you do if you have thousands of observations? It's going to be torture. Excel can do quite a bit. But if you're handling real industry data, biomedical data, maybe astrological data, the limitation of 17.1 billion cells per sheet on Excel is actually a humongous problem. That's a severe limitation to practical computations. And so R is the go-to problem to learn. If you're going to be using statistics in a job setting, this is very likely the package that you will be using. It's industry standard type software. And no matter how big your problem is, if you have trillions of terabytes of data, that might be kind of an exaggeration, but it's plausible. That's just fine. You just build a big enough system and R can handle that data. So that's the major reason we're not using the calculator or Excel. We're using what would be actually used on a real job site, say over here on the Idaho Falls campus. If you go that direction, you're over at the Willow Creek building where the Department of Energy does some interesting things. And I've had students tell me that's exactly what they use, just right over there. So how you get to RStudio, you can load this onto, say, a laptop, a desktop computer, and the link for getting it is right here. Oops, excuse me, right here. This is totally open source free software. So click on this RStudio link. It'll set you to on a step-by-step route for getting this installed. First place you'll go to is this right here on installing R. So this is a quick install. Let's click on just to see what it looks like. Takes you to this pretty basic looking web page. They don't need anything too fancy here. You'll have a couple options, R for Linux, Mac OS, or Windows. So pick your platform and you'll be all set up. Get that installed and you have R. Just kind of confusing because we often mention RStudio, but let me show you what R looks like. That's actually kind of hard to find. Where is R here? You know, it might not be worth the effort to try to find that. I don't think I see a quick way to actually find R. I think I just hit search on there. No, it opens up RStudio. Well, if you do this whole download right here, you get a program where you open it up. They'll look really basic, not what we're using in class, the actual RStudio program. But that's because we have to do the step 2, install RStudio. So this is the program that's really a lot nicer to use. Click on this. And let me see what it said there. Oh, we're already on the right page. I think that's what it's trying to tell me. Go down, find the platform that you're working on. So we have Windows, Mac, specific distributions of Linux, and just click on the install link there. So I can't actually install anything on this computer, but that'll get you started on dealing with R. Any questions at the moment, folks, about getting R or RStudio installed? Okay, basically that's kind of like our first homework day one assignment. I'd say if you came back to class on Wednesday, if you have RStudio installed on your go-to machine that you do most of your work on, you'll be in great shape. These programs are installed in just about every computer lab here at ISU. We're getting it installed in the 304 computer lab here on the Idaho Falls campus. I believe this program is installed by default on all the major computer labs as well on the Pocatello campus. And we'll be using it quite a lot in class as well. So this is what it looks like when it's all set up, ready to go. It looks kind of awful and scary at the moment, but we'll be working with this step by step to see just how it all works. Below, I just have some other quick articles for people who would like to know everything about a new computing system. Here's a quick repository of syntax for R. And this is just a quick blurb about statistics and study habits that you could take a look into. Also, blank lecture notes is kind of self-evident. We'll be uploading the solutions we put here, so if you ever need something blank, this would be a good place to go. That's pretty much the whole tour of Canvas. Every single thing that we do in class is going to be uploaded here some way, somehow. Every bit of progress we make in chapter 1, I'll be uploading all the solutions to that spot. Every bit of material that we need to go along with it will be posted below, and assignments will be relative to each one of the chapters. Then we'll just be going week by week. This is going to turn into one just gigantic resource of statistical methods, problems, and solutions. Well, I think that's the major introduction to Canvas at the moment. Any burning questions so far before we finish off looking over the syllabus? Okay, so back to the syllabus. Let's just scroll through this real quick. Well, I'll leave the objectives for you to read through it. These make a lot more sense once you've already gone through the class. As far as homework goes, I say I assign homework each week, but really the homework assignments are going to be relative to each chapter. Each chapter will have one homework assignment, and the moment we fully complete a chapter, the due date will just be a 1-week turnaround. So say we finish all the problems right here on our Wednesday's class, that means the due date for assignment 1, January 21, will become official. If we decide we just needed more time and we come back next week, I changed the due date, so it's always 1-week turnaround. That'll give you some time to work through the problems, get help, ask questions in class, and that kind of stuff. So that's going to be the pattern for how the homework is going to work. I wrote here, students are encouraged to work in groups on homework sets. So anyone that you might notice familiar if you're in Zoom, or anyone you might notice is familiar in class that you think you might want to work with, I think that's a great way to learn. It kind of, when you're working in groups, forces you to really think in terms of, do I really know this, as you explain something to someone else? And if you're just hearing information from a different person, a different human being, sometimes that's the best way to really learn something. All I ask if you do work in groups is write up your own solutions rather than say a verbatim copy paste of another student's assignment. You'll be in great shape. Exams are going to be pretty standard in this class. They're going to be 3 75-minute exams. We have a pretty big calculator, RStudio, so you might be wondering, how does this work on an exam? But really, the way my exams work is they're conceptual exams for the most part. You'll need a basic calculator for some routine computations, but anything that's heavy, anything that needed something out of RStudio, that's not going to be part of the exam. So if you had to have graphics in that problem, I print out those graphics. If there's a particular number you needed that you could only calculate through here, I put it inside the exam. So the exam is more about understanding how things work, making interpretations of conclusions, maybe doing a couple quick formulas, but nothing super heavy like we'll be doing with RStudio in the homework. So think of the homework as a lot more number crunching, graphic production. I think of the examinations as conceptual type questions. I'll be giving sample exam problems as well, so you'll know what kind of questions to expect on a real exam. We'll have 3 of them. They'll be standard in-person, on-paper kind of exams. I wrote some things like randomized seating charts. I don't know why I wrote that in. That's not really relevant. With half of us being in a testing center and the other half in the classroom. But any questions about either the homework or exam so far? Okay, one of the things I'm going to be doing pretty quick here, probably either this week or Monday of next week, is this class is kind of mixed up. We have an in-person section, an online section. In-person folks will be taking the exams in the classroom. The online section will be taking their exams in a testing center. So I'll be emailing all people individually just to double check which is your preferred location. Is it the Idaho Falls campus testing center, Pocatello testing center, or in the classroom? So once I have that all set up, I'll also be putting out instructions on how to schedule your exam if it's in a testing center and that kind of stuff. So as we get closer and closer to this week, more information starts showing up here, the exact coverage, the review problems, and that kind of stuff. So that's how the exams will work. Again, it's a pretty traditional looking class, except for the way it runs and the calculator we use. We have a pretty standard grading scale. But things to notice about the breakdown is it's a very homework heavy class. So that's 30%. It's worth more than the final exam outright. Exams are kind of standard at 15% each. The final exam is a little bit lower because it'll be a take home final exam. I've been debating on making this, say, a final project, but this is a hard class for a final project only because one of the things I'll mention a lot about this class is Math 3350 statistical methods does not have a prerequisite for introductory statistics whatsoever. So it's really an intro class, as weird as it sounds, a very, very fast paced intro class that uses some industry tools. But because of that, I felt like a final project is kind of a tough one for this class. Instead, the final exam is going to be a take-home exam, which is sort of like a final project, except I'll select between 6 to 10 questions, controlling it for the length so it's not too long. And you'll just be looking at different scenarios, different setups with data, doing a complete top to bottom analysis. So that's what the final exam is going to look like. It'll be kind of a glorified big homework assignment in a certain sense. Well, I've talked for 22 minutes. Any questions or comments at the moment, folks? Okay, well, yeah, sorry, go ahead. Yeah, absolutely. So for Zoom, the question was, am I going to be teaching how to use the RStudio program? And I would say yes, absolutely. One of the things that I do when I start using RStudio is, let me show you through an actual problem. So here's a problem right here where we're going to be using RStudio. That'll be through creating graphics that go along with these data. We'll go for just a basic bar chart. And yeah, it's going to turn into kind of a tricky thing to do on your own, but we're going to do it line by line, step by step. It's going to be basically like a quick live coding section. And everything we do right here, I'm going to bring it down here and just paste in what syntax did we use. So it all just shows up right there. And then when you go to do this homework assignment relative to this section, here's what it's going to look like. Assignment number 1. On assignment 1, you can open up either a Word file, a PDF file. I'll open up the PDF just because it's faster. My RStudio problems are very parallel with what we actually do in class. So you'll see once you go to do this homework set, the moment it loads up, you'll eventually come across a problem that looks like, say, this one. You'll construct a bar plot just like we did for class. You'll be able to look up, well, how did we do it? What did the syntax look like there? And you'll just change some numbers around to match your actual problem. So that's what the actual coding is going to look like for RStudio in class. There'll be a lot of time actually spent on how it all works in RStudio because just running through it is not the fastest or easiest way to learn this kind of stuff. It is pretty tricky at first. Another thing I mentioned as far as RStudio goes, let me see if I set it here. No, I did not. But one of the things I like to emphasize as far as RStudio goes is there's no secrets about it. So if you're doing homework and any issue comes up, any kind of error, you're welcome to email me at any time. You can say, take a screenshot of what you've typed out, send it to my ICU email address, say, hey, Mike, it's not producing the bar plot. I'm not sure what's going wrong. And I'll tell you exactly what's missing, help you fix the syntax. And in that way, even if we can't seem to get it to work, I'll give you a picture of what the bar plot looks, and you can just put it in your assignment so you can answer the next part. And we'll figure out what went wrong on your installation later on. So in other words, RStudio is just meant to be a tool. It's not going to be something that's major as far as course credit goes. Some of the problems on the homework are going to use RStudio directly, but I'm totally an open book as far as that goes. I'm not going to ever hold back information. If there's something wrong in your syntax, I'll send you the right syntax directly that you can copy and paste and just implement right here to get it working. Does that answer your question about how the coding will work? Yeah, you bet. One thing that's, again, really tricky about this is a lot of people take this class with zero experience in coding, and this is kind of a tricky thing to work out. So we'll take a lot of time breaking the system down to see how it goes. Other questions so far? Yeah.
For the process section, are we ever allowed to, like, if we're sick or something, attend the Zoom?
Yeah, absolutely. You're completely welcome to. So as far as it goes, I'm not too worried about what section you're in whatsoever. So if you're in the in-person section, you can come in through Zoom. And if you're on the online section, you can just come in person, CHE 215, any point of time during an ordinary class, during an exam setting, that'd be just fine. Absolutely. Thanks for asking about that. Other questions at the moment? Okay, just a side thought. One thing that's kind of tricky about this class is if you're in the online section, we'll have an exam on these days, but just note that means we don't actually have class on those days. Let me put the red dot in the right spot. We'll have no actual class. The in-person section will just meet in this classroom, and the online section will be scheduling an exam in the POCO Testing Center or the IF Testing Center and so on. So these will be days where we don't actually have class whatsoever, those 3 days there. And, well, that's the day-by-day schedule that we're taking a look into. I guess we're kind of out of material on this syllabus. There is university resources you should take a look into. Everything here in italics has been written by someone else. They're pretty standard statements, but every single one of them is important. So if you haven't read one of these, or maybe haven't read one recently, like Title IX of federal law, or other things like, say, accessibility, statements on success, these are good things to just browse through and become familiar with. But again, they're probably things you've read elsewhere. Aside from that, that's the whole entire syllabus. That didn't take too long. That's about 30 minutes so far. Let me close this out and get back to the Canvas website. So pretty much the way class is going to start every single day is there'll be a set of announcements. There might be some doodles on Canvas saying where we're at, what problem we're on. But we're always going to be scrolled to just about right where we are Canvas-wise. Right now we're in chapter 1, picturing distributions with graphs. And really chapters 1, chapters 2, they're kind of like get everyone on the same page kind of material. Because this class has no prerequisite for statistics, as weird as that sounds. I can't assume that everybody knows everything about, say, histograms, bar plots, left skew, right skew, all that kind of stuff. So we'll be going over that material. Apologies to people who have taken introductory statistics. You've probably seen this material already once before. We'll be going through it not as slowly in those classes. But again, it's just kind of chapter 1, chapter 2 is just getting brushed up and all on the same page type material. All the resources that we'll use is already up here. And I have it duplicated on my thumb drive as well for the particular chapter, everything that we need. So this is the experience. Class will start. We'll go right to where we're at. This is the chapter 1 lecture notes. So I pretty much just opened this file right here. This one is as a PDF. So if you rather have, say, something else, Microsoft Word, to annotate on your own, you can go here, like lecture notes. Click on that link. And I have the chapter 1 blank lecture notes as a Word file and as a PDF file as well. PDFs mainly for compatibility. And I guess another thing that's worth spending time on is, how do you do this class? There's lots of ways. So one thing you might want to do before you come to class is take a look at the Canvas page. I have everything posted before class starts. You'll know where we're at, where we're going. For the chapter 1, if you're a more traditional student, an ordinary notebook and pen is going to do just fine. But keep in mind, there are a lot of formulas here. Here's the formulas on this block. Here's another set of formulas, definitions on this block right here. The reason I put out these notes is so that as a person in class or on Zoom, your hand isn't writing, say, like 100 words per minute to try to get all that down. This is meant to save you time so you can focus in on the main things, filling in the solutions for each problem and concept. So even if you're doing things traditionally by hand, it might be a good idea to just print out these notes, or maybe just have them pulled up so you can refer to them as you go, as you're writing down on a notebook paper, and that would work out just fine. Other people might want to just download the notes from here or here, right onto your notebook, your tablet, and you can fill out the notes digitally like we'll be doing in class as well. I find that works out just fine. And some people just have found that it's okay to just have a blank piece of paper and just write down things that seem really, really vital, small things, and that would work out just fine. So there's lots of different learning strategies. Find what works best for you and just stick with it is my recommendation. And it's going to be the same with the homework assignments. The way I'm working the notes here is as if I'm doing a homework assignment down here. So that means if you like typing things out, you can type out all of your assignments directly on paper if you like. Or you can print out your homework assignments and just fill them out by hand. That would work out just fine. So just like with the notes, find out which way works the best for you. I'm happy to take your homework in lots of different modes. So I think most people traditionally are just going to type out or digitally annotate their homework assignments, just like the notes here. If you go that route, just save the assignment, save it as a PDF or a Word file, and you can digitally upload your assignment to Canvas. I turned off that option last semester because I was scared of it, so I'm going to learn it this semester. If you're worried about uploading it to Canvas, if there's any problems, if it doesn't like your file type, anything like that, you could just email it to me. This is the way I did all the homework assignments last semester. I just told everyone, email me your assignment, and that worked out just fine. So I'm still happy to do it that way. So you're always welcome to email the assignments. And you can just hand it to me on class if you're on the Idaho Falls campus. I'm happy to take something printed out, or if you wrote it out by hand, I can take your notes as well. So any one of those modes will work out just fine. Well, we'll be doing these notes again as if it was an assignment, except there's definitions above. And I'll just be digitally annotating the problems as we go. So I guess we're about ready to start, folks. We go from 1 to 2:15. We're hoping to finish chapter 1 this week, but if we get a little bit ahead or a little bit behind, that's just fine. The schedule isn't firm, it's tentative. So we'll go based off the class pacing. Any questions whatsoever, folks, before we begin in earnest? Okay. Well, one thing I should mention as well, I think I forgot, is if you're on the online section, definitely you kind of want to have a bigger screen. This doesn't work too great on a cell phone. An iPad is great if it's a slightly bigger one, but laptops and desktop computers are kind of what the resolution is going to be based off. It might be hard to actually see and read everything if you're on, say, a cell phone display. But if that's just the best way you could get on come in on that day, maybe there's an emergency, then that's the best we'll do on that day. Well, let's start off with some definitions. Statistics is concerned about populations and samples, as well as parameters and statistics. There's so much to say there. As short as these definitions are, there's lots of information. The population, formally defined, is just a collection of all persons or objects that we want to learn about. A parameter is typically a number that describes a population. So this sets up a dichotomy. Typical parameters that we'll be studying will look like this. So let's write in, let me fix this. Sorry, this works a little bit better with slightly less bold. There we go. For parameters, the typical ones we're going to see are going to look like this: mu and sigma. So that's the Greek letter mu, the Greek letter sigma. Mu is going to be the population. Mean. I wrote it possessive, the population's mean, or the population mean is synonymous. And sigma is going to be the population's standard deviation. STD for standard, DEV for deviation. Informally, the population's mean is going to tell us where all the central values are. We'll talk more about that in chapter 2. And the population standard deviation is going to tell us how spread out the individual values are as well. Another thing that's kind of weird is when you see the word mean, this just literally means average. So average and mean are going to be considered totally synonymous in this class. So those are the parameters that we're going to look into. Not all of them, but just a quick set of them. The trouble with these parameters are they're almost in every single situation that we're curious about unknown values. Our goal is to determine what is the approximate population's mean and standard deviation if we needed that. And we go through a sample in order to study that. We select a sample from the population, hopefully by using a rigorous sampling method. And a statistic is a number that describes a sample. So here's what typical statistics would look like. So here are our statistics. Well, corresponding to mu, the population's mean, is this value, x with a bar over it. We'll just read that as x bar. This is going to be the sample's mean. And likewise, this is a lowercase s. Let's try to make sure you don't draw it like the number 5. Lowercase s is going to be the sample's standard deviation. So those are the statistics that correspond to the unknown parameters. And here's one additional nice concept about statistics and parameters. Oh, that's not going to work. I'll just leave it there. Even though mu and sigma are almost always unknown values, we do have this nice concept. The unknown mu is going to be approximately equal to the known value x bar. So that's great. We have an awesome estimate right out of the gate for an unknown value, a value that describes something large, an entire population. Likewise for sigma, sigma is going to be approximately equal to the sample standard deviation s, and we'll know these numerical values. We'll calculate it ourselves. But here's the reason why this course is 16 weeks long. There's a big problem with what we wrote down right here, right at the red dot. It's not that it's approximately equal, that it's a bad estimate. These are very, very good estimates. And probability theory, sometimes these are called unbiased estimators and things along those lines. The problem is right here, where we said approximately equal to, that's just not good enough. Because if you say a population value is approximately equal to whatever that number is, people are going to ask you, well, how reliable is that? What is the margin of error in that estimate in the first place? And that's what makes this a big course. We need to say, how reliable is this? Or in other words, what is the margin of error? So this is what makes us 16 weeks long. We require the margin of error. And we'll see some really tricky, interesting ways on actually finding that. The normal distribution will come up, but we'll find out the normal distribution applies to a huge set of contexts, like this one right here. That's where we're going to get our margin of error computations from. Well, that's our quick discussion on the two major pairs of definitions, population versus sample, parameter versus statistic. Any questions or comments about that so far? Okay, well, it's just a few lines right here. It's extremely informationally dense. And if you're like me, sure, we can write down all these words, but I don't think I would really ever get a good sense of what a population mean really is or what the sample mean is really doing unless we throw in an example. So this is how the order of the notes, the logic of the notes is typically going to follow. Definitions or theorems or formulas as a quick discussion, and then an example to immediately target that. The homework is pretty parallel to what we're doing on these notes as well. So you'll have a different example one, but you'll be asked to do very similar things that we're doing in the notes as well. My favorite types of problems are these kinds that have a citation because this means it's real data, so real world data. Occasionally, if there's no citation, that's your indication that the problem is made up. That's still a good one to illustrate the examples. So we'll see quite a lot of problems like these. These problems are also tricky because the context is heavy. We have to break this down. But this alone is a huge statistical skill as well. It's a quantitative reasoning skill to take a wall of text like this, extract what's meaningful, what's really going on in terms of these objects here. So let's go through this carefully. It's kind of a major, just introductory topic as well to get us started for the whole course. And here's what it says to start us out. The ankle brachial index, I'll refer to that as just ABI for short, compares the blood pressure of a patient's arm to the blood pressure of a patient's leg. So we're going from extremes, arm to leg. So if everything is working great with your body, probably that these values aren't going to show off anything pathological. It tells us that ABI could be an indicator of different diseases, including arterial disease. So a healthy ABI is 0.09 or greater. This is never meant to be medical information, but we needed a value here, so here it is. And all this is just overall context in the statistical problem. So a real study was done, and here's how it went. In a study by McDermott and the others, titled Sex Differences in Peripheral Arterial Disease, published in that article there, the researchers obtained the ABI, recall that's the ankle brachial index, of 187 women with peripheral arterial disease. That number 187 is important. It describes the sample. It's how big the sample was. We'll often use N equals 187, where N is the size of the sample. Maybe it's not too important to write that down just now, but a lot of our problems are going to involve a good amount of formulas, and just the skill of reading through or writing down a symbol that could belong to that formula is going to be really big for us. So I'll be doing that just as a best practice kind of thing each time we break down one of these sets of contexts. So we have a sample of 187 women. Let's put that in blue just to indicate we're talking about a sample now. The results were a mean ABI of 0.64 and a standard deviation ABI of 0.15. So those values came from the sample. This is not the population. And you have to wonder, how would you even measure that for the population? You would have to somehow find every single woman with potential peripheral arterial disease, measure their ABI, and that's just impossible. They did it for 187 people, and that's already a gigantic amount of work. So when it says the mean ABI 0.67, we're not talking about this mean at all. That's the unknown in the whole problem. We're talking about the mean of the sample. So we would write in X bar is 0.64. And likewise, a standard deviation 0.15 would be S, not sigma. S equals 0.15. So those are the statistics they found from the sample of size 187. And this question here, it really doesn't belong because we're not really at that point to answer this question just yet. It's kind of a preview question. This is the kind of question we would like to answer once we have some statistical methods under our belt for statistical inference. At the 1% significance level, we'll have to say exactly what that means down the line in chapters 14 and 15. Think of this as a benchmark for evidence, 1% saying we want a lot of evidence before we make a conclusion. Do the data provide significant statistical evidence to conclude that, on average, women with peripheral arterial disease have an unhealthy ABI? Again, we can't really answer that just yet. I'm glad I didn't delete it because, again, it makes it a preview question. The sample mean is 0.64, healthy is 0.9 or greater. So it looks like, yeah, they're in the unhealthy range, but we can't make that conclusion just yet. Sure, we can say the unknown mu is approximately equal to X bar, but there is an error in that estimate. What's involved in that error is a standard deviation S. If that's pretty big, even with the mean 0.64 being below 0.9 in the unhealthy range, we might not actually have statistical evidence that all women have an unhealthy ABI when they have this particular disease. So let me just highlight this and make a quick comment where our goal here is for this question. Oh, that's the wrong tool. There we go. This is really just a preview question. It's a question we really cannot address just yet, but we'll be definitely in a great position to do that before midterms. So we'll probably come back to this direct problem and show how to analyze it top to bottom. Well, all we've done is read through the context, and this is the major skill in statistics. Every problem is a problem like this, basically a gigantic word problem. The context can be pretty tricky. It could be things way outside our expertise, interests, but that's okay. It's always going to give us enough information to attack the problem and move through it. So it says in part A, describe the underlying population of interest using the context. And this is the most important part right here. The context is all contained here. And let's think about this. When it said describe the population, that means we're going to talk about the entire collection of individuals we want to learn about. The population is not all people. The population is not all women. We have to be really particular when we go to write it out. But you know, the sample comes from the population. So if we read where the sample is indicated, we'll have a pretty good idea of what the population is in the very first place. So here it said we had 187 women with peripheral arterial disease. That is the sample. That means the underlying population should be all women with peripheral arterial disease, not just the 187. So that's one of the ways we'll kind of nail down what is a population in a problem. If they give us a sample, you probably have a good idea of the population itself. So we'll say here, all, to emphasize we're not talking about the sample anymore, we're talking about everyone with this condition. So the population will be all women with peripheral arterial disease. My penmanship improves over time. I get rusty over the break. But any questions at all, folks, with the population in the problem? Okay, once you have the population, the sample is a lot faster to write down. You could just say the 187 women with peripheral arterial disease. But you know, it's also fine to just say this. The 187 individuals selected. That is extremely brief. I didn't say a whole lot about those 187 individuals. The reason this is a full description of the sample is we know automatically that the sample came right from the population. So if you know what the population is in the very first place, you don't have to say a second time the 187 women with peripheral arterial disease. It's already implied the moment you said 187 it's 187 people from this group here. So sometimes you can be pretty brief with these kind of answers. If you said 187 women with peripheral arterial disease, that's just totally fine as well. But this is a decent shortcut to make occasionally, once we see the relationship between the population and the actual sample. So we know what we want to study, that's part A. We know how we're going to study it, that's part B. Select a random sample of everyone with that condition. We computed the statistics as well. And here is the next tough part. Describing the unknown parameters, as well as doing it with the context. Any questions or comments next, folks? Okay, this is actually kind of tough in a certain sense, part C. So we always make a pretty big deal out of this, describing a parameter. The major parameter that we would describe when we're further on the course would be mu, but we'll describe both just because we're learning both at the same time. What makes it tricky is there's a lot going on here. There's a lot of moving parts. There's population versus sample, but there's also, what did we measure? We measured an ABI at the same time. So when we go to describe the unknown parameters, here's what it's going to look like. First, it's mu. And if we see the definition above, sorry for the random scrolling, we know mu is the population's mean, but that's not good enough. We have to bring in the context. Mean of what? What population? That's the thing that's going to be missing. So we'll start off by saying mu equals the population mean. And here's the next thing we have to say. Mean of what quantity specifically? Well, that would be the population. The population mean of all women with arterial disease. Well, we have to say mean of what quantity? What are we taking the average of? What's the numeric value, the numeric thing that we're working with? So this is going to be the quantitative variable. Let me bump that up a little higher. Does that make sense to folks on what would go here? So this one's pretty short. You could just say the mean ABI, and that would do the job. The way we can think about that is, when we said mean right here, we have a sample mean right here, 0.64. We can reverse engineer it. It was a mean for ABI of 0.64. So we have to mention that here to really pull in the context. What are we taking an average of? It's the ankle brachial index, or ABI. But then the next part you said, all women with peripheral arterial disease, that's the next key that we have to put in. So first, well, not necessarily first, you could put these in any order, but this has to be one object that's here. The next thing we'll say is for all. Put in another blank. And here we mention the population. So population goes in here, and like you mentioned, it will be all women with peripheral arterial disease. And I mistargeted that. Let me try again. So these two keys right here, you have to say, what are you taking the mean of? Is it time, height, distance? Here it's ABI. And then you have to mention the actual population itself. Bring in both of those values, and you've got the definition of one parameter. So this is the unknown. This is the quantity that we would like to estimate as best as possible, as well as describe the margin of error in that estimate. We know mu is possibly 0.64, but again, we don't have any notion of what the error is in making that estimate. Any questions at all, folks, on nailing down mu? Okay, It's a tricky process, so we'll make a big deal out of it every single time. It depends on what's going on in the context, and there's a lot of judgment calls on deciding, do we say enough? For example, if you said the population mean ABI for all women, and you just stopped right there, you might lose a point. Not a whole bunch of points. Say it's a 3-point question on exam one, you might lose 1 point because it wasn't about all women. It was about women that had that specific condition. So think about, what is this study really about? In fact, a bit of role playing is a good idea here. Imagine you're in charge of the study. What is it the thing that you're trying to figure out fundamentally? And that will tell you what is the parameter. Well, that's plural this time. There's 2 parameters we'll describe, so let's go for sigma. But sigma is not too bad. If you found out what mu is, the only word you're changing is mean to standard deviation. So we'll say that sigma is the population standard deviation, usually abbreviated, for all women. Oh, hang on, we shouldn't jump to that. You have to say the standard deviation of what exactly? Standard deviation ABI, that's the main thing we're studying in this problem, for all women, with peripheral arterial disease. So we have the same elements there, but we're just describing a standard deviation. So we made that one switch. Well, does that make sense to folks at the moment? Yeah. Sorry, say again? Yeah, absolutely. Everything that I write down is going to be put in really 2 places. So you'll be able to see everything we did right here under recorded lectures in this playlist. But sometimes that's kind of hard to look up information scrubbing through a YouTube video. But after class ends, I delete this right here. I go to my thumb drive over on the right. This gets saved up as a PDF, and I just put it back over here. So wherever we end at, you'll know exactly where that spot is. And all the notes we take, they're going to stay like this. If I make a mistake, it's going to be forever. So let me know if you see anything weird on there. This one right here? Yeah, it kind of does in a sense. I think I draw it slightly similar as here as well. I'd say the best way to write sigma is, it's like you're doing the letter O, but then you just keep on going with the extra tail going off like that. So that would be kind of our different ways of drawing sigma. And you know, depending on how fancy you want to get with this, some people in this class also like to do this kind of stuff. Hit all plus on word, go slash, I'm not sure if that's forward or backward, and go sigma. You can type out really nice reports for just about any symbol you can imagine. U goes like that, X bar goes like, not like that, X bar goes like that. So if you would like to just type out everything, that absolutely works. You don't have to, because that's a lot of extra effort, I would say. But if you're ever curious on how to put in a symbol, don't hesitate to ask. I'll be happy to help out. Other questions at the moment? Okay. Well, I think we're through the hard parts. The parameters is the gnarly bit about all this. When it says state the value of the statistics, or the values, well, we kind of have them already. This is really just seeing if you can extract them from the context above. We did that once. X bar is 0.64. And S is 0.15. Really, we didn't have to interpret them, say what they are with the context. If we wanted to, we would say the mean for the 187 women selected in the study for their ABI was at 0.64. But we're just stating the values for this part. And we did it. We now know that this mu is approximately equal to 0.64. But again, that's just not good enough for us, because we need to also encapsulate how spread out the data is and construct a margin of error in making that estimate. But we did it. That's our first example for the entire semester. Any questions or comments at the moment? Yeah.
So for the, like that, like the, mean for the statistics.
Yeah, that's exactly right. So just give me a number, put a symbol here, either in words or using the actual symbol we're using so I know which is which, and that'll do the job. And I try to be pretty careful with instructions. So anytime I want a bit more, I'll always try to have this printed out using the context. It's going to be like a buzzword for us. If I say wrote an exam question and I just forgot to say that using the context, well, that would have been my bad. And if you just said use the population mean, you would have gotten full credit because I didn't bake in what I wanted in the actual instructions. So I try to be very literal with instructions, especially if I'm taking off points as well. And if I just left it there, that meant I just wanted the numerical values, like you said. Other questions so far? Okay, well, that's example one. Again, the assignment is going to be very parallel to what we do in the lecture notes. So if you're thinking about taking a look at the assignment, that's a pretty good strategy. Here it is, assignment number one. Keep in mind, if you're in the habit of doing the assignments early, there's a lot of stuff here we haven't even touched on whatsoever, but let's just download this. Here it is, and you'll notice example one, totally different problem. This is about acid rain. This is not about all acid rain affecting the pH of lakes. This is specifically high mountain lakes. We're not talking about high mountain lakes on the entire planet. We're talking specifically high mountain lakes in the Southern Alps. That's what the population is going to be, all high mountain lakes in the Southern Alps. The main point of pulling this up is you'll notice it's kind of the same sort of problem. Not every single problem is going to be perfectly parallel, but that's kind of my goal with the lecture notes as well as the homework exercises. If you do a problem and you feel like I'm just not too sure what this is about, we might have done concepts or even a whole question that was very similar to this. And you're always, at any point, welcome to just ask. You can come into office hours if you get a little bit lost in the homework assignment. You can send me a direct email and I'll be happy to help out. So if you get stuck at any time, whether about the context or about the RStudio, don't hesitate to email. I'll be very happy to help out. Well, let's see how much time we've got. We've got about 13 minutes. And here's the next wall of text to take a look into. So we mentioned that we were looking into a particular data type. We might have accidentally said the word quantitative variable as well in the last problem. Data can come in a lot of different kinds of ways. And some statistical studies have many different types of data that we're going to analyze, different kinds of variables. So here's the next dichotomy we're looking into: a quantitative variable versus a categorical variable. What we mean by variable is any characteristic of an individual that can differ from one individual to a next. And we get a full set of data by taking observations on everyone in the sample across all the variables of interest. So the last problem was involving a quantitative variable. And that just means for every single person in that sample, 187 women, we made some numerical measurement. So that's a dead giveaway, it's quantitative, but another thought is a quantitative variable often has units. A quantitative variable will make sense to take the average of or the mean of. And I think that's the main things I wanted to say about a quantitative variable. The next classification of variables are then categorical, or you might call them qualitative. A variable becomes categorical if we're not making a numerical measurement. We're just classifying people according to what condition they may have. So two good examples of categorical variables could be, say, blood type. Maybe in that study they did take blood type into account, and we're only seeing the result from the ABI variable. Blood type is categorical because for every single person in the sample, we're just saying which one of these can we classify you as: O negative, A plus, AB plus, and so on. It doesn't make sense to average any of these values whatsoever, and so that's what would make that variable categorical, blood type. And it gets confusing because, say, for example, zip codes. They're numbers, they look numeric, but they are also categorical variables. So just because we see a number doesn't automatically imply it's a quantitative variable. A zip code is literally categorizing people according to their geographic regions. If I have a set of zip codes and I average them, the average of those zip codes is completely nonsensical. It's not a geographic region whatsoever. And so that means zip codes would be considered a categorical variable. There's really no unit to a zip code. Averaging them doesn't make any sense at all. And that causes them to be categorical. So with that information, we're going to take a look into this data set down below. This is a data set that has, looks like 5 different variables. We just want to understand the nature of all those variables as we go through it. Any questions or comments at the moment, folks, for the differences between quantitative versus categorical? Okay, in the reading, you'll also notice that there's different kinds of quantitative variables. There's continuous versus discrete. There's different kinds of categorical variables, ordinal versus nominal. But because our actual statistical methods in our book doesn't really get into the fine details between those kinds, this is the major takeaway that we'll be seeing in the homework exercises as a concept question as well. So I'm not going to split it into the different types since we're not really investigating that whatsoever throughout the semester. Here's our first data set then to take a look into. This one's about the forced expiratory volume. We'll call it FEV just for short. It's going to be measured in liters, and it's an indicator of lung function or lung strength. If you ever had, say, pneumonia or know someone who has, they've probably had an FEV value measured in some way, shape, or form. And it corresponds to the volume of air that can be forcefully blown out in the first second after full inspiration. So you take a full breath of air to the best of your ability, exhale as forcefully as possible, and some kind of device, maybe a Wright meter device, is going to say how strong your lungs are in terms of the FEV value. So that's the overall context. The specific context is we have a particularly interesting data set. The FEV data file contains FEV values for a large sample of children, along with some descriptions of each individual. This is real-world data, it turns out, even though I don't have a citation here. This comes out of our textbook. Here's just a snippet of that pretty large data set. These children are young, some of them are teenagers. Those vertical dots you see are just my way of saying, I cut off the data set here because this is pages and pages long. We just see the top of the data set. So we have 3 variables that look pretty quantitative, but then the other 2 look quantitative as well, being numbers. But it says sex and smoke with 0s or 1s. I don't see any 1s in the smoke column, but presumably there might be. In the sex column, here's the definition. 0 corresponds to female, 1 will correspond to male. In the smoke column, 0 will correspond to non-smoking, and 1 will correspond to smoking. Kind of a weird way to record data, but occasionally with real-world data sets, even categorical variables can be recorded as 0s and 1s. These are now considered categorical variables for both sex and smoke. Let's take another quick look at this data set because it is a pretty interesting one. It's this one right here if you want to download it, fev.txt. I have it pre-downloaded here on the thumb drive. And here is that data set. So as you scroll through this, notice that the far right is the smoking column. It's mostly 0s, but 1s do come up. They're just kind of hard to spot. So here's one row where a 1 comes up. Another thing to notice is that this is a gigantic data set. I really can't say much about it by just trying to scroll through it. The 1s are just of particular interest to me. So to really work with this data, first we would want to do some exploratory data analysis by getting some visualizations of maybe what does the FEV variable look like? What does this variable look like if we split it across whether the children were smoking or not, which category they belong to? We'll be doing some of that kind of work in chapter 1 and chapter 2. So this is a data set we'll come back to. But for the moment, all we're looking into is, for each variable, determine if the variable is categorical or quantitative. Categorical meaning we just took each one of those children and put them in some category. Quantitative meaning we made a numerical measurement. There's some kind of unit attached, and the average probably makes sense in this data set. Well, this one's not too tricky to get through. Would you all agree that age, FEV, and height do make sense as quantitative variables? Awesome. So this is a quick one to get through. This one is not too tricky. It makes sense to ask about the average age in the data set, the average FEV value for lung strength and height. So let's just say here, for quantitative, we want to indicate which ones are quantitative, and that would just be the age variable, then FEV, then height. Then as far as the categorical variables go, again, this one is kind of tricky, right? It's easy to kind of just miscategorize, I shouldn't say categorize, misunderstand these as being quantitative variables because they look numeric. The whole purpose of the 0 and 1s is to classify the children in this data set as belonging to one category or another for each one of these variables. So it says if the variable is categorical, also describe its categories. So we'll say categorical are sex, where 0 corresponds to female, 1 corresponds to male, and the smoke variable, where 0 is the good outcome, non-smoking, and 1 is the very concerning outcome, smoking. I do want to say one thing about this data set. It seems really, really awful when we talk about, say, here's a 14-year-old child. I think we saw a 10-year-old child that is considered to be in the smoking category. But this is a study where if you really want to understand exactly what's going on in this problem, you would have to read the article, figure out what they meant by smoke. It's a classification. One there could mean maybe the child is exposed to secondhand smoke at home, not necessarily that they're lighting up cigarettes. It's just it's in their environment. We don't know that for sure until we read the whole study and see what's going on. That makes these statistical problems kind of challenging because these are really short abstracts. You're never required to go download the study, read the whole thing, which could be like 30 pages, and you might have to pay for it. You just go based off what was provided, the best we can. But we did it, folks. That's what classifying the variables is going to look like for this kind of problem. We'll do some more work with this data set later on and other data sets, but I think this is probably a good stopping point. Any questions or comments at the moment with any of the concepts so far? Okay, always try to respect your time and end right at 2:15 if possible. Sometimes our problems are a little bit long, so I'll end just before, call for questions like we did just now. So I'll try to target that 2:15, but it's going to be challenging to be right on the minute. And after class ends, pretty much what I'm going to be doing is saving this as a PDF like we mentioned, rewriting this PDF with the solutions we have so far. So if you still need a blank file, say, crap, I want to download that to write out myself, which is a great way to learn this material, go to the blank lecture notes where you can find that file. And if you say had to just leave class and you needed to come back to see what you missed, everything is going to be recorded. And that's the next thing I'll do is put our recording into this playlist here. Sometimes YouTube does take a while for the video to be encoded or whatever it does, compressed and become available. But I try to get that posted as soon as possible. Well, at this point, we have a good idea about how class is going to run day by day. Any last questions or comments at all, folks, before we call it a day? Okay, well, have a great afternoon. If you do have questions, just feel free to stick around. Like I mentioned, office hours starts officially at 2:30, but I'm pretty much just going to be in this classroom the whole time unless I have to take a quick break. But take care, folks. I'll see you all on Wednesday. Any questions?
Yes, I was just looking over the exam schedule